Students, now we will derive an expression for the electric field due to a long wire carrying a uniformly distributed charge. Electric field due to a long wire carrying a uniformly distributed charge. Now, to understand the derivation, we should know what is known as linear charge density. What is linear charge density? Linear charge density is charge per unit length. It is given by the symbol lambda. Lambda is Q by L. So, linear charge density is called charge per unit length. Lambda is nothing but linear charge density, which is nothing but charge per unit length. So, charge per unit length is called as linear charge density. And of course, you should understand, for the entire length, the charge Q is distributed across the wire. For example, I have a wire over which the positive charge is distributed, and let the total charge be Q, and the total length of the wire is L, and therefore the linear charge density is lambda is given by total charge divided by the total length of the wire. It is called charge per unit length, or it is also called as linear charge density. இது புரியறதுக்கு ரொம்ப கஷ்டம்லாம் பட வேண்டாம். மொத்தமா you got 10 rupees அப்படின்னு வச்சுக்கலாம். 10 rupees is distributed among 5 people அப்படின்னு சொன்னா, then amount per people, per person will be 10 by 5. அங்க வந்து amount is distributed with respect to number of persons. இங்க வந்து charge is distributed with respect to the length. இந்த length தான் நம்ம number of person எடுத்துக்கிறோம். இங்க வந்து 5 சென்டிமீட்டர் எடுத்துக்கலாம். Charge is 10 coulomb எடுத்துக்கலாம். If the total charge is 10 coulomb and length is 5 centimeter, then your lambda is 10 divided by 5, which is nothing but 2, so much of coulomb centimeter inverse, or it is called as coulomb per centimeter. So, to understand this derivation, one should know the idea of what is known as charge per unit length, or it is also called as linear charge density. Now, we will go to the derivation part of the corresponding electric field. Please register that lambda is called as linear charge density, and which is given by Q by L. Now, consider a wire over which positive charge of value Q is distributed over the entire length L, and therefore we know that lambda will be equal to Q by L, which is nothing but linear charge density. Consider a midpoint O of the entire length, drop a perpendicular through O. Now, identify, it is our duty to find electric field at this point because of this long wire. Electric field due to a long wire carrying a uniformly distributed charge. This is a long wire. Of course, we have defined the length as L. When I say long, then it will stretch from, if you assume this point as 0, then this is plus infinity and this is minus infinity. When it stretches to infinity, then we say the wire becomes long wire. Now, it is our duty to find the electric field at this point. If in the point we have to find the electric field. To find the electric field at that point, because of the entire wire, choose wire portion of length X let the small portion be dx. The charge on that dx will be, the charge across this dx will be dq will be equal to lambda times of dx, because lambda is charge per unit length. ஒரு கத்திரிக்காய் வந்து lambda-னா அப்ப dx கத்திரிக்காய் எவ்வளோ, just multiply by dx. Similarly, ஒரு unit price is nothing but lambda. அப்ப therefore what is the total price? Total price is the quantity multiplied by unit price. lambdaன்றது ஒரு சென்டிமீட்டருக்கு இருக்கிற சார்ஜ், ஒரு சென்டிமீட்டருக்கு சார்ஜ் வந்து lambda-னா அப்ப dx சென்டிமீட்டருக்கு எவ்வளோ, dx சென்டிமீட்டருக்கு it is dx into lambda. That is what I have given as lambda times of dx. Therefore, now we know the charge across this length is your dq, which is given by lambda times of dx. Now we have to find the electric field at this point. Join the point and the corresponding elemental charge. That dx portion is called as elemental charge, and that elemental charge is given by the value dq is nothing but lambda times of dx. Now this charge will exert an electric field at that point. So what is the electric field because of this charge? And that electric field is small, which is represented as dE, because the charge is dq. The direction of the electric field will be along the line of action. So this is the direction of the electric field, which is dE. Now what is the value of the electric field? We know the formula that the electric field value is kq by r square. Maybe in the last session we have derived. So the electric field because of the point charge is k into q by r square, where k is your constant, which is 9.9 into 10 power 9 corresponding units. Q is the charge of reference and r is the distance between the point of reference and the charge. So this formula already we know. Now here dE, which is the electric field at this point because of this charge, will be equal to k times, instead of q we have dq divided by, let this distance be your r, and therefore it is r square. So dE is equal to k into dq by r square. So further proceeding, we should know, or we should assume, the distance of the element from the center is x. Let this distance be x and let this distance be y. Therefore we can write the expression r square equal to x square plus y square. From Pythagoras theorem, r square equal to x square plus y square, I can replace this r square by x square plus y square, and therefore dE will be equal to k times dq divided by your x square plus y square. Now what is your dq? As we all know that dq is lambda times of dx. I can substitute here, and therefore dE will be equal to k into lambda times of dx divided by x square plus y square the whole square, x square plus y square. Now we have found the electric field at the point P because of the elemental charge dq. Now the direction of the electric field is along the line of action, this is which is represented here. Let this angle be theta. In the angle theta எடுத்தோம்னா, then we can resolve the electric field into two components, along the vertical and along the horizontal. This electric field can be resolved into two components. One is, if this angle is theta, then this angle is also theta, and therefore this vector is dE cos theta and this vector is dE sin theta. So for a small electric field dE, because of the charge, elemental charge dq at the point P, the dE can be divided into two components. One is dE cos theta, other one is dE sin theta. Suppose if I were to consider another elemental charge on the other side of the origin or other side of the midpoint, this my midpoint is O, consider another elemental charge which is at the same distance. Let me assume this is also x. Join your P and the corresponding current element. Now when you extend this, I have another set of electric field which is again dE, and if this angle is theta, this is also theta because it forms an isosceles triangle, and hence this d again can be resolved into two components. One is d sin theta here and d cos theta along the vertical. So இந்த பக்கம் இருக்கிற எலிமெண்ட் மாதிரியே இந்த பக்கம் ஒரு எலிமெண்ட் எடுத்துட்டா அந்த எலிமெண்டோட electric field will be along in this direction similar to this d, and that can be resolved into two components, d cos theta here and d sin theta along the opposite to the direction of this d sin theta. There is one more horizontal component in this direction. In the d sin theta, this d sin theta will cancel out each other because they are equal and opposite. So what is the point is, இதுல என்ன நம்ம புரிஞ்சுக்கணும்னா, சென்டருக்கு ரைட் ஹேண்ட் சைடுல ஒரு எலிமெண்ட் இருந்ததுன்னா அந்த எலிமெண்ட்டுக்கு இருக்கிற நெட் எலக்ட்ரிக் ஃபீல்டுக்கு ரெண்டு காம்பனன்ட், ஒன் இஸ் d cos theta which is along the vertical component and d sin theta which is along the horizontal direction. Whereas similar current element, similar elemental charge, when I take a similar elemental charge, I have the net electric field dE. Again, if this is theta, this is also theta because it forms an isosceles triangle, and if this theta, this angle is also theta, and hence again dE can be resolved into two components, d cos theta and d sin theta. From this d sin theta and another d sin theta this side will cancel out each other, and hence the net component is only d cos theta, which will not cancel out. So இந்த பக்கம் இருக்கிற infinitesimally small elemental charges எவ்வளவு எடுத்துட்டாலும் அதுக்கு ஈக்குவலா இந்த பக்கமும் elemental charges இருக்கும். அந்த ரெண்டு elemental charges ஓட horizontal component, which is called as d sin theta on both sides, will cancel out and only vertical component will remain. All the vertical components are pointed in the same direction and therefore they get summed up. எல்லாம் மொத்தமா ஆட் ஆயிடும். இப்போ இதோட வெக்டர் vertical direction இங்க இருக்கு, இதோட வெக்டர் இங்க இருக்கு. இதே மாதிரி இன்னொரு எலிமெண்ட் எடுத்தோம்னா அந்த எலிமெண்டோட வெக்டரும் அங்கே தான் இருக்கும், d cos theta. And therefore here the total electric field E is nothing but sum of all the, when I say sum, it is integration of all the components, which is d cos theta, integral of all the components of d cos theta. d sin theta will not come into picture because d sin theta will cancel out. Corresponding components of d sin theta on both sides will cancel out and only d cos theta will get summed up. Therefore E equal to integral d cos theta. Now we know the value of d as k into lambda into dx divided by x square plus y square, and we should know what is cos theta. Cos theta from this triangle, cos theta will be equal to, we know cos theta is adjacent side by your hypotenuse, and therefore y divided by your r. So it is y by r. Instead of r, I can write it is root of x square plus y square. So therefore it is y by root of x square plus y square. Hence substituting your d value, k into lambda dx divided by x square plus y square, k into lambda dx divided by x square plus y square multiplied by cos theta. Cos theta is y by root of x square plus y square. Y divided by root of x square plus y square. Now I can take all the constants outside. K is a constant, we can take it outside. Lambda, it is linear charge density, which is also a constant. Adhi velathalam. Y, this distance is fixed because we are not going to move this point. In the distance fixed. So y, we can take it outside, and x is a variable, therefore dx should be inside the operator, and x square plus y square, this term, even though y is there, but it is in the summation, and therefore it is a total term which contains the variable x square, and hence it should not be pulled outside. Now k lambda y integral dx divided by x square plus y square, the whole power 3 by 2, because this is x, this is a, this is root a into root a power 1 into a power half, a power 1 plus half, which is a power 3 by 2. Now this is the expression for the electric field. We have not found the final expression, it is the intermediate value. Now we have to integrate this to get the value of the electric field. Before integration, we should know the limit. We have to supply the limit. Now when I say long wire, this end stretches up to infinity. This end will stretch up to minus infinity, and therefore your dx will vary from, or x will vary from minus infinity to plus infinity. Here x is equal to minus infinity to x is equal to plus infinity. The limit is very, very important, children. We should remember the limit, because when I say long wire, it's not a definite length. It is a long wire. When I say long wire, then from 0 to infinity, from 0 to this side is minus infinity, and therefore your x is a variable which varies from minus infinity this side to plus infinity that side. That is what the limit. Now here comes into role. The major part of this particular problem is not the physical concept. Physical concept can be easily understood. Now it is the idea of your integration. How to integrate this equation dx divided by x square plus y square the whole power 3 by 2. For doing that, let me rub the previously written information, holding some of the information in the board itself, because I may require for further arguments. So, the diagram I keep for our reference. Now, E equal to k lambda y into integral minus infinity to plus infinity dx divided by x square plus y square. Now, what is the substitution? Your x is equal to, put x is equal to y into tan theta. Because this is the form, we can simplify this expression as 1 plus tan square theta. Secant square theta is 1 plus tan square theta. We can also go as cosecant square theta is equal to 1 plus cos square theta. In the rendu formula use pannalam. Now I am going to use your tan theta, and the formula is secant square theta is equal to 1 plus tan square theta. In the formula reduce panna, then we can remove that power half, rational powers we can remove. Y is equal to x is equal to y tan theta. Now when x is minus infinity, we should know the limit of operation. When x is minus infinity, when x is plus infinity. When x is minus infinity, when I say infinity, tan 90 is infinity. Tan 90 is infinity. And therefore, when x is minus infinity, your tan theta is minus infinity, we can say nothing but directly we can say minus pi by 2. And similarly here theta is equal to plus pi by 2. So we have changed the limit. Now simplifying this particular expression, what is your dx? Dx is nothing but y into, y is a constant. When I differentiate tan theta, it is secant square theta into d theta. Now simplifying the expression x square plus y square is equal to, x is nothing but y tan theta. So y square tan square theta plus y square, I can remove y square outside and say it is tan square theta plus 1, and 1 plus tan square theta is secant square theta, therefore y square into secant square theta. And hence x square plus y square will be equal to y square into secant square theta. Now we have to substitute in this expression x square plus y square and dx and all the limits. Therefore your E is equal to k is a constant, lambda into y into integral. What is the limit? Limit is theta is minus pi by 2 to plus pi by 2. Instead of dx, we have y secant square theta d theta divided by, instead of x square plus y square, we have y square secant square theta, and therefore y square secant square theta the whole power 3 by 2. The whole power 3 by 2. Now this y square secant square, this power 1 by 2 will get cancelled out, and therefore k equal to k into lambda y. Theta is minus pi by 2 to plus pi by 2 is the limit. Y secant square theta d theta divided by, when you simplify this expression, you will get y secant theta the whole cube, because this power half will get cancelled out. Now we have got y secant square theta into theta divided by y secant theta the whole cube. This secant square and secant will get cancelled out. We will have 1 secant theta in the denominator. This y and this y and this y, it is put together y square. Here y cube we have, and therefore 1y will get cancelled, and therefore E is equal to k lambda y square divided by y cube into theta is minus pi by 2 to plus pi by 2, and your secant square theta d theta divided by secant cube theta. Cancelling the like terms, we have k into lambda divided by y into minus pi by 2 to plus pi by 2, you can cancel one of the secant square and say it is d theta divided by secant theta. Now for want of space, I shall rub the remaining portion on the right hand side and complete the derivation. Please be strong in mathematics if you want to be strong in physics. E equal to k into lambda divided by y, k into lambda by y. Now integral theta is again minus pi by 2 to plus pi by 2. The 1 by secant theta is cos theta. So it is cos theta d theta. E equal to k lambda by y. Integral cos is sin theta. Upper limit is pi by 2 and lower limit is minus pi by 2. So E equal to k lambda by y. Apply the limit, sin 90 minus lower limit is equal to k lambda by y. Sin 90 is 1 minus of minus 1, which is equal to k lambda by y, which is 1 plus 1, which is nothing but 2. So k lambda by y multiplied by 2. Now again we can simplify this. Instead of k, I can substitute 1 by 4 pi epsilon naught and skip simply y as y and lambda as lambda. We have 1 by 4 pi epsilon naught into lambda into 2 divided by y. Simplifying, we have E is equal to, net E will be equal to, you can cancel this 2 and 4 and say it is 2 in the denominator, lambda divided by 2 pi epsilon naught y. So E is equal to lambda divided by 2 pi epsilon naught y. So this is the final expression of electric field at a point because of a long wire carrying a uniformly distributed charge of Q, and its direction is given by radially outward. Now the wire is here, this is the radially outward direction. D is the net E will be in this direction because we are summing up all the dE cos theta, and therefore the net direction is, the electric field is radially outward. It can be either this side, if the point P is below, then dE cos theta will point downward. Upward and downward, we need not tell upward and downward, we can say it is radially outward. If it is positive charge, it is going to be radially outward. If it is negative charge, it is going to be radially inward. So children, please be thorough with the basic concepts of mathematics and ideas of physics to integrate both and complete the derivation. For deriving any vector quantity, one should derive the final expression, which is the magnitude, as well as we should explicitly say the direction of the electric field. So finally, the electric field, because of or at a point due to a long wire carrying a uniformly distributed charge, is given by E equal to lambda divided by 2 pi epsilon naught y, where lambda is the linear charge density, y is the distance of the point from the midpoint of the wire, and the direction of the electric field is radially outward. Please do practice, children.